All right, we're back, and it looks like everything transitioned over nicely from my last section of videos into this one. I had some kind of weird issues at the end where I couldn't doodle on my little screen, so I paused it at that point, reset my iPad, and we're hopefully back now, but ideally I'm not going to lose the ability to doodle, because in this section we get to talk about lightsabers for the entire section. I should preface this that I'm not, super duper knowledgeable on all things Star Wars. I guess a little bit too young to know some of the really old school Star Wars knowledge, and that like I grew up right when episode 1 was coming out. So I watched Star Wars in the right order, which is probably going to make many of you very, very mad, in that I watched them 1, 2, 3, 4, 5, 6, and then the most recent trilogy as well, and then all the other side quests as well. So I grew up seeing like Darth Maul as my first Star Wars, villain with the super awesome, lightsaber that goes out both sides. But for this video, I drew a nice little Kylo Ren lightsaber, which has the two little like nubs coming out on the end. I'm sure some of you out there have way more knowledge of Star Wars and can be like, well, there's also this random person who has a lightsaber similar to Kylo Ren's that has these two little nubs, but it's going to be something else. And, the Kyber crystal inside of that emerged from some other area and it causes all these other properties. But I don't go that deep on Star Wars. I know some amount of it, but not nearly as deep as the rest of you probably are. We also have, I guess, Kylo Ren here fighting, I don't know, probably Luke or Obi-Wan or something like that with a nice little green lightsaber, or just generic person with a green lightsaber, which again, I'll probably get an email from some of you being like, here, all the people that had green lightsabers that would have more accurately fought Kylo Ren and blah, 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 which is awesome. One of my good friends and colleagues is a Star Wars buff, so I'll talk to him after I'm done recording this video and being like, I just totally lied to all my students about a whole bunch of Star Wars stuff. But we're not actually going to talk about Star Wars and things like that the entire video. We're actually going to be talking about a crypto system, which is called CRYSTALS-Kyber. Not to be confused with Kyber crystals, which is obviously the goods that make these, lightsabers actually function. Again, some of you are going to be like, well, this emerged from this other area. And I'm going to be like, okay, I know the name and I know a little bit of it, but please tell me far, far more about it. The crypto community obviously is filled with nerds and we love it and it's great. So we totally like making, plays off of other known things. And that's what's going on here as well. So the crypto system is called CRYSTALS-Kyber, not Kyber Crystal, to avoid being sued, I guess. And probably going to have issues if I've said these words enough times. When I actually shove this video into YouTube, it might get flagged for some amount of like copyright infringement of like, you used a lot of Star Wars verbs and words in this section. So we're going to delay, allowing this video to be until we fully vet it. And then they're going to see this video and be like, okay, this is totally fine. Let's just let this thing ride. So the crypto system is again called CRYSTALS-Kyber. As I've mentioned in a few other videos, as well as some emails, it's actually our kind of finalist in our NIST post-quantum standardization. So we went in with 4 of them a couple summers ago, and then emerged with 1 of them on the backside. So CRYSTALS-Kyber being it. We're going to play around with it today, just to kind of talk about where it emerges from, how it plays off of some of the in-true landscape, basically kind of these two things fused together a little bit. They do keep the Macaulay's system, so the error correcting code-based system is kind of one on standby. So I still do want to take a couple weeks at the end of the semester to chat a little bit about some of these error correcting codes. Basically, in the NIST post-quantum standardization, we went full hard on like the lattice space stuff, but we still also want to kind of keep some of them in our back pocket of like, just in case lattices break, let's have something at the ready. So we're still going to talk about some of the error correcting code stuff just because A, it's really cool, and B, it's one that we should just kind of still keep in our back pocket. What it'll mean for us in our discussion of this realm is that I'm probably going to restrict all of the attention just to the encryption of single bits, and then kind of leave the later discussion of how to pre-process and post-process some of those longer strings into those things as kind of up for your own reading. They do a pretty nice job of talking about it in the actual original presentation, at least the kind of round 3 presentation of CRYSTALS-Kyber, that they kind of talk about how you would take one of these things, do some XORing, do some, fancy hashing to feed some of these things in. So I'll let you kind of take a peek at that, and we'll fully nerd out on the math that makes a single bit operation work, because that's really where the core of it stems from. And then once you know that it works for like single bits, then again, you can do some fancy concatenation and XORing and things like that to then allow other types of messages as well. So that's kind of our game plan for both, I guess, this section as well as the next couple of sections, is that we'll play around in this landscape, but I still want to leave enough time to do some of the error correcting code goodies as well, just because it is really sweet and I don't want you to miss out on it. But CRYSTALS-Kyber is on the docket for today, so that's going to be what we're going to emerge into. If you're coming in from the last section, again, I mentioned some of the needed functionality for us to kind of jump into this world. So some things like how we're going to generate some of our random numbers. So I want to just really quickly talk about that before we jump into it, just to kind of make sure we're all on the same page. So obviously we have a pretty easy ability to generate just like uniform random numbers. So if you wanted to generate numbers between 0 and 6, so what, there'd be 7 of them. So 0, 1, 2, 3, 4, 5, and 6. You could totally do that. You're going to have a pretty big range of numbers. So you can have numbers all the way as small as 0, as well as all the way up to 6. And they're going to have, essentially each the same 1/7 chance of emerging. What we want to do is we're going to shift those things over so we can kind of center these things at 0. So you have 0, 1, 2, 3, and then -1, -2, -3. The range is still the same. We're still having, these 7 total numbers. The distance from the biggest number to the smallest number is the same length, but the size of these numbers then start being a little bit smaller. What we further want to do then is we're not going to look at this as a uniform distribution. We're hoping to then see more numbers in this kind of middle bin of stuff, and then fewer numbers that are going to emerge out on the tails. And the reason for that is because we want these little things to still stay relatively small in terms of their average size or their average number, but we still want to allow the, potential of having some bigger ones. So when it comes from the attacking side of things, it's going to say, well, this little vector S and this little vector E were generated by having, 500 numbers, and those numbers range from -10 to 10. Even though most of them are going to be between, -1 and 1, I still want the ability that I can say, well, it could be a 10 or it could be a -10. So you got to still test all 21 things, even though most of the weight's going to come from the middle one. So it becomes a pretty cheap way to expand out some of those ranges while still having the bulk of our stuff be at a somewhat smaller level. The way that we're going to generate these things, so thinking back to the numbers from -3 to 3, what we're going to do is we're basically going to generate a random number from 0 to 3, and then we're going to subtract off one of these numbers from 0 to 3. So that gives us this range from -3 up to +3, and then it's going to create this nice little shape that's going to look like that. So a good amount of bulk in the middle and then less on the edges. So we'll see that once we get into the code. That was one of the things that I had originally presented in this notes, and then or this set of notes. Then I was like, no, we need to talk more about that. So I shoved it into the previous section. So if you by accident missed that section because there is not necessarily an activity connected to it, there'd be a little bit more about that in the activity for this section, but then the more formal discussion of it then would have occurred in the last section of notes. So I'm probably going to pause it there. The next thing I'm going to briefly chat about is going to be this notion of compression. So while we're not doing the full like XORing and concatenation, pre-processing stuff, there'll still be a layer of compression and decompression that's going to occur in this process. So we're at least going to talk about it from some of the smaller single number side of things and then flex it up to some vectors. And then that'll give us some fodder as we jump into our actual crypto system. So I'll pause it there and we'll come back in a second.